Hello GeoTriggers. In this video I'm going to show you how to graph this transform function. However, there is a slight typo, not necessarily a typo. The transform function and the way that the x-axis here is labeled make it really difficult to graph this transform function on this axis. So instead of adding an extra level of difficulty in, if we just change this b value to 2, our finalized numbers will fit very well on this graph, and that might just be nicer. So let's go with that. Okay, so in order to graph this function, I need to know the parent values of secant before I can transform those values. So we may have to go back to our notes from the other day when we graphed the parent function of secant. Okay, I really need you to learn these key values over here. Okay, so let's make sure we can create this parent function at the drop of a hat so that we can work on the transformation. So I'm going to record these key values in my chart over here. Key values are 1, undefined, -1, undefined, and 1. The x values that correspond to those y values have to fulfill a full period of secant, and a full period of secant is 2 pi. Okay, well, if I break that up out of one revolution, that would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So here's my parent function key values of secant. Now for the transformation, let's start with the y values. This is sort of a typo. Let's think of it like this. We know that secant does not have an amplitude. However, it still has the possibility for a vertical stretch. Okay, so if cosine is secant's reciprocal function and cosine has an amplitude, you can see very lightly here my dashed cosine function. If cosine has an amplitude and we stretch that amplitude, that would also move the base of these parabola-shaped curves on the secant function. So we still would have to apply that value. In this case, the a value is 1, and multiplying by 1 does nothing to the y values. So the y values stay the same. Okay, now for the vertical shift. Okay, this is the d value, and here d is equal to -4, which means the whole function is going to come down 4 places, so I'm going to subtract 4 from every y value. Don't be tricked by these undefineds. Remember that an undefined represents a vertical asymptote, and if you move a vertical asymptote down, it's still vertical in the same spot. Okay, so I have subtracted 4 from each y value. Now this set of y values is obsolete. This set of y values is obsolete. These are the y values that I'm going to graph on my final graph. All right, now for the transformation of the x values. First, I have to apply a period change. In order to do that, I can go back to the formula for a transformed period, which is the transformed period is equal to the original period divided by b. So in this case, the original period of secant is 2 pi. The b value here we have changed to 2 to be a little more friendly on our graph, which reduces to pi. So basically, we're taking 2 pi and we're cutting the period in half to be just pi, which means all the other values of x will also change. So we are going to divide each x value by 2. 0 divided by 2 is 0. Pi over 2 divided by 2 is pi over 4. Pi divided by 2 is pi over 2. 3 pi divided by 2 is 3 pi over 4. That means these x values are now obsolete and we're looking at the period x values. The last adjustment to the graph comes from the phase shift, which involves B and C. The formula for phase shift is C divided by B. Okay, well, my C value, don't be tricked here. Remember that the formula calls for theta minus C here. In order for that sign to have ever been a minus, the C value must be a negative pi. And the B value is 2, which means I'm going to move each x value left 2. And to do that, I want to left pi over 2. And to do that, I want to subtract pi over 2. So 0 minus pi over 2 is negative pi over 2. Pi over 4 minus pi over 2, if you want to do that fraction math, pi over 4 minus pi over 2. Here's the deal with fractions. You have to have a common denominator. So I'm going to rewrite this as pi over 4 minus 2 pi over 4 so that I have a common denominator, which would make negative pi over 4. Pi over 2 minus pi over 2 is 0. I have another opportunity to practice my fractions here. 3, start a new problem. 3 pi over 4 minus pi over 2, and I'm going to write pi over 2 as 2 pi over 4, would be 1 pi over 4. And then pi minus pi over 2, there's another chance to practice your fractions if you need to. Pi minus pi over 2. Well, now pi needs to be written with a common denominator, so that would be 2 pi over 2 minus pi over 2 would leave us with 1 pi over 2. All right, this is all fraction math. Feel free to do that in your calculator if you want to. That makes the period column obsolete. These are the two columns I'm going to use to finally graph my function. Okay. Well, if pi over 2 is 2 units to the right, then negative pi over 2 is 2 units to the left, and down 3. Pi over 4 is exactly halfway between 0 and negative pi over 2. So pi over 4 is represented by this first line to the left of the y-axis, and that value is undefined, which means there's a vertical asymptote there. 0, negative 5, that's an easy one to graph. Pi over 4 is halfway between 0 and pi over 2, so this first line to the right of the y-intercept is pi over 4, and that is another asymptote. And then pi over 2 has a value of negative 3. Okay, if this doesn't look like enough to graph the function, it might mean that you're not really aware of what the parent function would look like. So let's look again. Here's our parent function of secant. Okay, an upward facing parabola shape, sort of a parabola shape, followed by a downward facing one and then an upward facing one. So here, we're going to go up towards the asymptote. This key point would be the top of the function. And this one's going to go up towards the asymptote again. Now I need to be able to repeat my function, so follow the pattern, okay? There's an asymptote every 2 blocks. Follow the pattern. Put in all the other asymptotes. Okay. Then I want to keep my pattern going. This is an upward facing piece of the function. Then I need a downward facing, which means it has to have the same key point. Now I need an upward facing. It needs to have the same key point. Now a downward facing to finish it off. You have finished your graph of this function.